Hey guys, Mr. Ferguson here on Wrestling with Math. Today we're going to do a video on the quadratic formula. So my example that I'm going to have here is x squared minus 5x minus 14 equals 0. You see the quadratic formula is here given to us like it would on the Regents exam, like it would on any reference sheet that we may have. What the quadratic formula is doing is it's finding the solutions to a quadratic equation. Other names that we have for solutions are zeros, x-intercepts, and roots. It's the points where this equation will cross over the x-axis. So my formula here, it has x equals negative b plus or minus the square root, b squared minus 4ac all over 2a. What I first need to do is I need to identify my a, my b, and my c values. Okay, so things to consider. I need to have my quadratic equation set equal to 0. That's step 1. Step 2, it needs to be in standard form, which it is, highest exponent to lowest. And sometimes, depending on the situation, we would say that the x squared term has to be positive. For the quadratic formula, it does not have to be the case. So my a value, just like the alphabet is a, b, c, my a value is my coefficient of my x squared term. So in this case, a is 1. B is the coefficient of my x term, which is negative 5. And c is my constant, which is negative 14. From here, I take my values and I'm going to plug them in the quadratic formula. So I have x equals, and anywhere where we see a letter, we're going to replace with a set of parentheses and substitute my values in. So that negative sign is in the formula. My b value is negative 5 plus or minus the square root, and it's really important to use parentheses here. Negative 5 squared minus 4, a is 1, and c is negative 14. And this whole thing is over 2 times a, which is 1. Seems like a confusing step, but all I did was substitute my values in. From here, I'm going to simplify. So I tell my students to plug what's underneath the square root sign into their calculator, not including the square root symbol. So if I were to simplify this, I plug this whole thing in with parentheses. Okay, this here underneath the square root sign gives me 81. So I'm going to simplify this here. 2 negatives make a positive, plus or minus the square root of 81 over 2. Now I look to see if this number is a perfect square. 81 is one of our perfect squares, so I can simplify it. X equals 5, plus or minus the square root of 81 is 9 over 2. Okay? Now I continue simplifying here. The plus or minus usually means 2 solutions here. So what I do off to the side, I take 5 plus 9 and divide it by 2, and I take 5 minus 9 and divide by 2. The top one here, 5 plus 9 is 14. 14 divided by 2 is 7. And I take my bottom one, 5 minus 9 is negative 4. Negative 4 divided by 2 is negative 2. X equals negative 2. So my 2 solutions are x equals 7 and x equals negative 2. This would be the 2 points where it crosses the x-axis. Those would be my solutions, my roots, my x-intercepts. I'm going to do one more example, but it's going to be on the screen. All right, so we're going to do one more example of the quadratic formula. This one, the only difference is that it's not going to be a perfect square underneath that square root. So I have, it is set equal to 0 here. It is in standard form, so I'm going to identify my a, my b, and my c values. A, in this case, again, is the coefficient of my x squared, which is 4. B is my coefficient of my x term, which is 4. And c is my constant, which is negative 9. I substitute into the formula. I used the formula just before, so I'm not going to rewrite it here. Negative sign, parentheses, my b value is 4, plus or minus the square root. B squared minus 4 times a times c here, all over 2 times a, which is 4. Again, I tell my students to plug in what's underneath the square root sign, not including the square root symbol. Again, this is going to be extremely important for this step. So I have x equals right here. This just becomes negative 4 plus or minus the square root. If I plug this whole thing in just like you see it with parentheses, you get 160. over 8. Now, 160 is not a perfect square. I have to see if there are any perfect square factors of 160. If you're looking at this, you could see that, well, 16 has to be 1. 16 is a perfect square. It's going to be the largest perfect square times 10. Okay, the square root of 16 is 4. Square root of 10 cannot be simplified. That just stays as a square root of 10. So what I could do is I could replace 160 with 4 times the square root of 10. Okay, so I'm just going to give myself a little bit of room here. X equals negative 4 plus or minus 4 square root of 10 over 8. Now, in the previous example, I split it up based on the plus and minus, which I can't do that here. Well, I could, but it won't really do much. I can't do that here because I have this square root of 10. It's like a variable here. It's not like terms. But I can see if the number here, the coefficient of your square root, and the denominator here have something in common, which they all do. They are all divisible by 4. So I can rewrite this as x equals negative 1 plus or minus, I'm just going to, for purposes of this video, write the 1 there, 10 over 2. So, in simplest radical form is what they'll say. We have our two answers here, x equals negative 1 plus or minus 1 square root of 10 over 2. If you did have to round it to the nearest hundredth or tenth, you would plug in the square root of 10 into your calculator and simplify like we did before. So, again, 2 different examples for you guys, and hope this helped you guys out a lot. Thanks a lot, guys.